Today we'll be talking about, the comparison between autonomic nervous system and somatic nervous system. This is very important for pharmacology class. So we know that somatic nervous system, as it's related to soma, which means related to body or muscles. So you could see the first difference that we see that the body of the neuron is in the central nervous system, while the axon is coming out, which is myelinated, and it's reaching to the muscle where it's going to release acetylcholine, which means this neuron that's releasing it is cholinergic, which means releasing acetylcholine. And it's going to work on the muscle, it's going to make neuromuscular junction and going to stimulate the muscle. Now, the thing is that this acetylcholine has receptor on the muscle, which is the nicotinic receptor, uh, nicotinic N or N receptor, NM receptor, which means muscle here, that is stimulatory. So whenever we have um, acetylcholine working on the skeletal muscle, it's always going to excite. So that's what we know. Now, when we come to the other part, which is autonomic nervous system, we know autonomic nervous system has two parts. There are three parts, but here it's shown two: parasympathetic and sympathetic. Now you could see that sympathetic itself, both of them have two other neurons. In comparison to this one, it has one other neuron. Here we have two other neurons. So this is the body here, as we see, of autonomic, and then we have one neuron finishes here, and then we have second order neuron here in similar fashion. And then you could see that you could see here first order neurons of sympathetic is relatively shorter, so the body which will end, the second body which is going to start, it's going to be near the spinal cord, which means central nervous system, which means it's going to make a ganglion. These ganglion are very near to the vertebral column, while here in parasympathetic the first order neuron is relatively elongated, while the post order neuron, second order neuron, is relatively shorter. So the ganglion that would be made, the body that would be not near the central nervous system, which will be near the organ that you see a lot of times in the visceras. When we see organs, we are near the organs, we see ganglion. That means it's related to the parasympathetic. Um, what else do we see here? The first order neuron or the preganglionic neuron, whether sympathetic or parasympathetic, all of them are releasing acetylcholine. You can see all of them are releasing acetylcholine, and they also have nicotinic receptor on the second order neuron, the receptor. But this receptor is also nicotinic, but we call it N neuron. So N receptor we have. While in sympathetic, the second order neuron, it's unmyelinated. That's the first thing. Second thing, it's releasing norepinephrine or epinephrine. Yes, it's releasing a lot of norepinephrine, but small amount of epinephrine. Now we know that the epinephrine or norepinephrine, whether this is excitatory or inhibitory, depends on the receptor. And there are alpha receptors and beta receptors. And then we divide them alpha 1, alpha 2, beta 1, beta 2. So whether norepinephrine is going to be excitatory or inhibitory depends on the receptor. Another stuff that we have for sympathetic also works on the adrenal medulla of suprarenal gland. Here it releases also acetylcholine, but here we don't have the second order neuron. The second order neuron has been modified into hormonal, endocrine gland, which is releasing epinephrine a lot, small amount of norepinephrine. Now this epinephrine is slightly different because it's going to go into the blood, and from the blood it's going to go into the whole body. Now when we come to parasympathetic second order neuron is also releasing acetylcholine, just like the first order neuron of other autonomic nervous system. Here it is, but the receptor is different on the organ. The receptor would be muscarinic receptor, right? Now this muscarinic, there are 5 different types of muscarinic receptors. Thank you very much. Hope to have more lectures on pharmacology.